Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will learn how to calculate the variance and standard deviation of a discrete probability distribution. So in a previous video, we learned how to calculate the expected value of a discrete probability distribution. That's the value that we expect to occur. That is like if we perform the experiment heaps and heaps of times, that's the average of the values that will occur. The variance is related to this idea, but it doesn't tell us what we expect to happen, what the mean is. It tells us how much the random variable, the value it actually takes, deviates from the expected value. So the lower the variance, that means that the values that actually come up are closer to the expected value. And if you have a high variance, high variability, it means that the actual values that eventuate are quite different. They're often quite a distance away from the expected value. The standard deviation is just the square root of the variance, and you can think of this as the average distance from the mean. Now, we've come across standard deviations when we talk about test marks. So if the mean is like 60 and the standard deviation is 10, that's just saying that like on average, each student was within 10 of the mean. Once again, the higher the standard deviation, the more variability, the more spread out the scores were. We'll also just quickly touch on mode, but mode's really easy. It's just the value that has the highest chance of occurring. So this is how you actually calculate the variance. You find the expected value of x squared and you minus the expected value all squared. And then this just says standard deviation of x, you just square root the variance. All right. Probably not making a lot of sense now. Let's look at this distribution here and we'll actually calculate the variance. So to calculate the variance, we need the expected value of x squared. So what we're going to need to do is make another row in our distribution. And that row is just the x squared values. So these are the x values. All we need to do is square them. So if x is 1, x squared is 1. X is 2, x squared is 4, 9, 16, 25. So again, I just got each of these values by squaring the x value up here. So firstly, we're going to calculate this, the expected value of x squared. So now it's like x squared's our random variable. We know how to calculate expected value. We just take each value, multiply by its probability. Each value, multiply by its probability, and then we add up all of these. So the expected value of x squared here, it will be x squared value times its probability. Plus the next x squared value was 4 times its probability. Plus the next x squared value times its probability, and so on for all the values of x squared. So putting that in our calculator, we should get 10.2. That's not the variance, it's just the expected value of x squared. So now we're going to calculate the expected value of x just like we did previous video. We take each value of x and times by its probability. So the next one's going to be 2 times 0.2 and so on. So expected value of x squared, we use these values timesing the probabilities, and when we're calculating just the expected value of x, it's these values multiplied by the probabilities. So putting all that in our calculator, we get 3. The expected value or mean of this distribution is 3. So now we're going to use this number and this number to calculate the variance. So the variance is just the expected value of x squared minus the expected value all squared. So the variance here is just 1.2. That is the variance of this distribution. So the standard deviation of this distribution is just the square root of the variance, about 1.095. So that's saying that on average, each score is about 1.1 from the mean, and the mean we calculated was 3. So lastly, the mode of this distribution, well, it's just 3 as well, because 3 has the highest probability of occurring. And remember, of course, distributions can be bimodal or multimodal. They can have more than one mode. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.